Hello everyone, this is Dr. Indradeep Kumar, Assistant Professor IARE, Hyderabad. So in this video, we will see Shear of open and closed section beam. Okay, so our lecture topic will be Shear of open section beam and Shear of closed section beam. Okay, so first let's start with the Shear of open section beam. Okay, the open section beam of arbitrary section shown in figure. So this just we have taken this open section beam, right? So just see from here this side it's a open one. Okay, support shear load Sx and Sy. So just see here, this is here it's showing Sx and Sy. Okay, so here Sx and Sy is there. Okay, such that there is no twisting of the beam cross section. Means this force or that Sx and Sy should be such that there is no twisting, that should not get twisted. Means it's just applying the load, that's all. There means at some particular angle it's not done, so that it should not get twist. Okay, for this condition to be valid, the shear load must both pass through a particular point in the cross section known as shear center. So when that is possible, if we will apply the force and that beam won't get twisted, when we will apply the force at that shear center. So at shear center we have to apply the force so that there is no twisting in that one. Since there are no hoop stress because of this open is there, so no hoop stress will be there in the beam. The shear flow and direct stress acting on element of the beam wall are related by. So this is what del q by del s plus t del sigma z by z. So just see here s varying over the surface and sigma z stress along the z direction varying with the z. Right? That must be equal to 0. Okay. So now taking moment. Okay. So moment, let's see here del mb by del z, that is equals to force, right? Why? Because force is equals to what? Force into perpendicular moment, right? Force into perpendicular distance gives moment. So force will be what? Moment by d. Now check here. So Sx is our force. So Sx in x direction will be equals to what? Del m by del d. So d is here z. So del z. So that's why it's written here. And so on, this expression becomes, now just substituting the moment equation, this is what? Sigma z by dou z, that is stress. So that load in x direction into moment of inertia Ix, that crosses that section property that in previous video we had seen. So Sx Ixx minus Sy Ixy divided by moment of inertia in that one. So Ixx into Iyy minus I square xy into x. So just see this one Sx, so in x direction, right? Now similarly for y, so Sy, just see how to remember this one. Sx Ixx is there, so similarly Sy Iyy will be there. Now here Sx is there, so next term will be Sy. So Sy Ixy. So here for x means negative will be y. For y we are finding, so for that negative x will be there. So Sx minus Ixy divided by, in both the cases that will be same, Ixx Iyy minus I square xy. This derivation already we had seen. That's why I just use this one. Now substituting for delta sigma z by del z. Okay, so now what we will get, that del q by del s equals to negative of what? Sigma, just in this equation, just here. So here substituting del q by del s, okay, plus t del sigma z by del z. So here we are substituting this one, right? So we can say that t, right, del sigma z by dz equals to minus del q by del s, or simply just you can put minus here. So del q by del s equals to minus t into sigma z by del z. Okay, so just we will use this and substitute here that del z, that sigma z by del z value. Okay, so after substituting here, just here this t term get multiplied, or in another word, simply let me simplify this further. So what we have, this is delta. So formula is del q by del s equals to t minus t into what? Sigma del sigma z by del z. So del sigma z value is sx ixx minus what? Sy ixy by ixx into iyy minus ixy square. This into x minus next what? For this is for x, so now for y. So sy iyy minus sxi xy by ixx into iyy minus I square xy into y. So now multiply t. So after multiplying t, what happened? Here this t will be there and here also t. So here that is. So minus sixx because this term is plus. So here after multiplying will be minus. So minus sx ixx minus sy ixy by ixx iyy minus I square xy tx minus sx iyy minus sx ixy by ixx iyy minus I square xy into ty. So after substituting the value of sigma del sigma z by del sigma z by del z. Okay, now just integrate this one from where to where? Over the entire surface, means from 0 to s. Okay, so after integrating, what we have to do with respect to ds only we have to integrate. So del qi ds into del s into ds. So after integrating, what we will get? That as qs, that's shear stress over entire span. Right, now just see here, this term is constant, right? So this term is constant, that will be out of integration. So what will we have to integrate? 0 to s dx dx. Similarly from this term will be constant, that is out of the integration, and you have to integrate 0 to s dy ds. Okay, next, so qs equals to minus this one. So after finding this only we will get that integrating qs equals to this 0 to integral t x ds minus this constant term here, this is here, and 0 to s dy ds. So just integrated this part here and this remaining whole thing is here same. Okay, just write down. Now next step will be what? Right, so just see, at that condition here it will be there when sy is, just see, or here you can say when s or when I xy is 0 along that terminal. So I xy is 0 means what happened? So now substituting here I xy in that direction, it's not there. So moment of inertia along the I xy will be 0. So let's put in that one. So what we have? Okay, so minus, so I xy as 0. So after putting that, what we will get? Here sx ixx minus sy into ixy is 0. So 0 divided by ixx into iyy minus 0 square. So from here what we will get? I'm just simplifying first term. Right. So from this term 0, so what we will get? sx ixx by ixx into iyy. So ixx cancel, what we will get? sx by iyy. So just see here, sx by iyy we got. Now simplify for this term. Let's see what we are getting here. Okay, so now what we have? sy iyy minus sxi xy by ixx into iyy minus I square xy, right? So again we are putting ixy is 0. So this will be sy iyy minus sx into 0 by ixx into iyy minus 0 square, or just 0. So this will give sy iyy by ixx into iyy. So from here iyy will get cancelled. What we will get? Sy by ixx. So just here, that is here, right? And then integral of 0 to s dx dx minus sy by ix 0 to s dy ds. Just this integration. Clear? So now we have till this one. So after that, what is the next step? That we have to integrate. Okay, so just see here. So this is our final this one. So from the above equation, that is from the previous equation, okay, for the shear flow distribution in the cross section of an open section beam is based on the equilibrium equation. So that must be equal to 0, right? The thickness T in this equation refers to the direct stress carrying thickness TD, that already we had seen that figure also while converting into the boom area, that T is TD. So same thing you have to replace just here T as TD. Above equation may be therefore be written as. So this equation we are writing, right? This equation. In that we are putting T as TDS. So here now just see this will be there and TD instead of TX dx. Now this becomes TD x. So TD subscript is of that direct thickness experiencing direct stress. Okay, TDYDS, in which TD equals to T if the skin is fully effective in carrying direct stress, or TD equals to 0 if the skin is assumed to carry only shear stress. So if shear, that skin will carry the direct stress also, that completely, that time TD will be equals to T. And if skin is not carrying any direct stress, only the shear stress, that time TD will be equals to 0. So that already we converted that TD equals to 0 for the boom area, and that time we assumed what? Only the shear stress, not the direct stress. Again, the section property in above equation refer to the direct stress carrying area of section. So just here again we are getting what? Direct stress only, right? So above equation makes no provision for the effect of boom. So with this, why? Because there is no this one direct stress, only the shear stress is there. If direct stress is not there, then what is the provision of boom? There is no effect of boom, which causes discontinuities in the skin and therefore interrupts the shear flow. That means what? After if there is no effect of boom, then the skin will get damaged, okay, and which interrupts the shear flow. Consider the equilibrium of rth boom, whatever the type is there. Suppose that 10 are there. So in fifth one, boom in the elemental length of beam shown in figure 2. So here that is there, right? So this is the boom, okay, just once I will come then, okay, which carries shear load Sx and Sy acting through its shear center S. So Sx and Sy, that must be acting through shear center only there is, because why? No twist is required. That should not get twisted. If you will apply anywhere, then twist will be there at the center only. There is no twist. So now just see, this is here. After converting that stringer as far, these are the boom area, right? So these are just boom. So anywhere from 1, 2, 3, 4, 5, 6, any number. So from here, just imagine this is the rth boom, whose coordinate is xr, yr. That is, this is delta z, that is length of the boom. Now along the shear center Sx and Sy is acting. So now this we have to what? Next step is idealization. Okay. So now just see, first figure A is elemental length of shear loaded open section. Okay. With beam with boom. Second, equilibrium of the boom. So now this is the boom rth. Now we are considering only this one. Okay, and finding, and then we can take R value as 1, 2, 10, 1, 2, 3, 4, whatever the number of booms will be there, that one. Okay, so now Q2 shear stress that will act here in this direction, Q1 in this direction for this side, right? So just see here, Q1 and Q2 for up this side is acting like this. Okay, and Q1 and Q2 and Q1 for this surface, it's acting like this. Here sigma z is there, so definitely this side sigma z plus whatever the small change in the stress that will be there. So sigma z plus del z by dou z into del z, that will act here. Okay, so our Q2 over this will act in this direction and Q1 will act in this direction. Okay, now for this figure we have to find same again by we have had seen in the previous video. Okay, so now that means earlier what we found B1, B2, that boom area. So that we will use here, that is required. So we have to find the shear stress distribution. The shear load produces direct stress due to bending in the boom and skin and shear stress in the skin. So just see here again, these shear load produces direct stress because of this shear load, that sigma, okay, due to bending in the boom and skin and shear stresses in the skin. So bending and what happened? Direct stress will be in boom and shear stress will be in the skin. Okay, so bending and this will be there. Just see, produce direct stress due to bending in the boom and skin. So direct stress will be because of the bending in the boom and skin, and shear stress will be only in the skin. Suppose that shear flow in the skin adjacent to the RF boom of cross-sectional area BR, that already we have seen in the figure, that BR, B1 for first, like previous video, only 1 and 2 boom was there, so B1, B2. Now here, we just assume any RF boom. For that, we have to find. Same again, just like take the moment about any point, wherever that is there, right? So just see, sigma, okay, so this is the force, that is, sorry, stress into area, will give force, stress into area, okay, then again shear stress into area and shear stress into area. So just see here, whatever the direction is acting in this direction, so this and this one, let's see, this direction Q2, let's see, in this direction Q2 and this is acting, so this into BR plus Q2 into BR, and for this direction sigma z, okay, and in this direction, so if these two are positive and this Q1 and sigma z will be negative, so that here sigma, and for Q2 it's a delta z, and for Q1 also it's delta z. Why? Because we have taken here that as delta z. Okay, so now after further simplifying, what we will get, just to take common whatever, or just first expand this one, or let's see, I'm just expanding, okay, just multiply, so sigma 2 BR, sorry, sigma z BR plus del sigma z by del z into BR, right, this simplified, minus sigma z BR plus Q2 sigma z, sorry, delta z minus Q1 delta z, that is equals to 0. Now just see here, sigma to BR and sigma to BR cancel, right? Now take these two terms that side. So here just see, Q1 is negative and Q2 is positive. So after going that side, what is left this side? This side it's left del sigma z by del z into del z BR, okay, plus, okay, just I'm writing first equation, Q2, okay, del z minus Q1 del z, that is equals to 0, right? Now keep this side and take this to this side. So after that, what we will get here, Q2, I am taking del z common, so Q2 minus Q1. Why del z? Because here del z is there, so that we can cancel it. That is equals to what? Del sigma z by del z, okay, into del z into BR, that is with minus sign. Why? Because this side it will goes to minus. Now this del z cancel, okay, then what we will get? Q2 minus Q1, okay, that is equals to minus del sigma z by del z into BR. So just see here that we got here, Q2 minus Q1 equals to minus del sigma z by del z into BR. Now this del sigma z by dz we have from the previous equation, just substitute there directly, okay. So and just here it's replace Sx and Sy, right? So because here already we had seen in the previous one, just the Sx as del mb by del z, so that just replaced here, okay, in terms of moment, okay. So after that, what we will get, just further simplify, this is for what? Bx into Br and Br Yr, okay. Now, so after further simplifying, or just you can substitute here also in this one, or here Sx Sy, or just here this is there, that simply, or you can say this direct value is there, so this direct also you can use, so depending upon what is required. So what we are doing, we are substituting after m, that is this, next we are coming to this one, so hence we are substituting, okay, here. So finally we will get this here, Q2 minus Q1 equals to Sx Ixx minus Sy Iyy by Ixx Iyy minus I square xy into Br xr minus Sy Ixx minus Sx Ixy by Ixx Iyy minus I square xy into Br By, okay. So this is the shear stress distributed, that Q2 minus Q1. Equation gives the change in shear flow, that's why Q2 minus Q1 is what? Change in shear flow. Whatever is the change, that is change. So Q is your shear flow. So that's why change in shear flow induced by a boom which itself is subjected to a direct load what? Sigma z into BR. Now suppose first boom we are taking, then this will be what? Q2 minus Q1 over the first boom. Okay, Sx Ixx minus Sy Ixy by Ixx Iyy minus I square xy into B1 for first boom XR minus Sy Iyy minus Sx Ixy by Ixx Iyy minus I square xy into B1 YR. Okay, so just we have to change this R to B1, B2, B3, whatever the number is there. And on that one, what direct load will be there? Sigma Z into B1. For B2, sigma Z into B2. For B3, sigma Z into B3. Like that, only that will be there. Okay, now each time a boom is encountered, the shear flow is incremented by this amount, so that if any distance s around the profile of the section and boom have been passed, the shear flow at the point is given minus what? That is for what? How many are there? Number of booms. So for number of booms, what? R equals to 1 to n. Just simply we have to take whatever the number is there. If 5 is there, then R equals to 1 to 5, and this one will be B1. Okay, B1 x1, B2 x2, sum of, that is sum of B1 x1 plus B2 x2 plus B3 x3. So overall that QS total will be what? The sum of this, sum of Q2 minus Q1, because that is delta 1, and here that QS, that's all C. So this 3dx we have to substitute there, right? So after this, Sx minus this one, so just see this into this into this. Once you will apply, the total will be there. So Sx Ixx minus Sy Ixy by Ixx Iyy minus I square xy, okay, into, just after taking this common, because this is in both the term, 0 to s T dx into ds, where Td is the thickness containing the direct stress, plus this is how many numbers of booms are there for that booms. If 5 booms, means R equals to 1 to 5. If 10 booms, means R equals to 1 to 10. And along, according to that only, this also will change. That is B1 x1 plus B2 x2 plus B3 x3, so on up to B10 x10. Okay, so this is for this. Minus, again that Sy term will be common. So Sy Iyy minus Sx Ixx by Ixx minus into Iyy minus I square xy. Okay, into 0 to s T d y ds plus R equals to 1 to n, again same like this, whatever the number will be there, the same in both the cases, and will be and should be same. Okay, B R and Y R. Okay, and one more thing, don't take common here, just like Ixx is common or Iyy. There is no common term, right? Ixy stands for in xy plane, right? It's not like that Ix or Iy you can take the common from this one. No, you cannot. Ixx means in xx plane or along that x-axis. Like suppose this is x, y, right? So Ixx means along the x-axis. This is Ixx. This is y means along this line. So this is y positive, y negative, and this x is positive. So along positive, negative x, or you can say along the x-axis, this is Ixx. Along the y-axis, this is Iyy. Clear? And when xy is there, means in this plane somewhere it is, not over this axis, because it's rotating about, or moment of inertia about anywhere. So in x, Ixx, or along this you can say. Okay, so in xy plane, not along the axis. So this should be in the plane, and this is meaning, this having meaning in the what? Along the axis. Now, arguments identical to those in the shear of open section beam apply in this case. Thus, the shear flow at any point around the cross section of a closed section beam comprising boom and skin of direct stress carrying thickness Td is just that Td if is there, right? So Qs equals to it's just a previous one. Qs equals to Sx Ixx. This Tds we have to. So Qs, okay, equals to Sx Ixx minus Sy Ixy by Ixx Iyy minus I square xy into 0 to t Tdx ds plus R equals to 1 sigma R equals to 1 to n Br xr. This term already explained. Minus Sy Iyy minus Sx Ixy by Ixx into Iyy minus I square xy whole into 0 to s integral of Td into y into ds plus sigma R equals to 1 to n Br into yr whole plus this QS naught. Okay, note that zero value of the basic or open section shear flow at the cut in a skin for which TD equals to 0 extend from cut to the adjacent. So see, note that the zero value of this basic or open section, whatever the open section is there, shear flow at the cut, where that figure in that we had seen this cut was there, right? Okay, in a skin for TD that is equals to 0, extend from the cut, from wherever the cut is there to the adjacent boom. We suppose that figure is there or here. So from here to the next boom, wherever boom will be there, right? Or just suppose this boom is not there. So TD from here to the till next boom, that thickness that is required. Cut the adjacent boom. So here now just see this one term is there. With this one term only, it's a different, that QS comma 0, that S0 means when at the surface when it's a closed one, right? So this whole thing will be for open one. Once we will add Y, because that shear stress will be there. Once we will close any section over the surface, that S also will be there, means at 0 distance whatever the shear stress will be there, that QS 0. So now if we will add this term, that becomes for the closed one. That's why in starting I derived for the open one, and whatever the shear stress for the closed part will be there, just add it here. So now this will be, so just see here it's there, cross section of a closed section beam. So because of that, this term will get added. Okay, so now finally we got this as the for the closed one. Okay, so let me just recall once again. Okay, shear of an open beam. So first what we will see the open section beam, and in that once we will derive that one, later we will add the closed part of that one. So means shear stress containing the closed part. Okay, so first what we did, we applied that force, our load, and along x axis and y axis, that is Sx and Sy. So without twist means there is no twist should be there. So for no twist means what? That force should be applied at the shear center. So we applied that force at the shear center. Because of that, there is no twist. Now again, the open section is there, means there is no hoop stress, right? For that closed one, hoop stress will be there. Only that difference will be there. Hoop stress, that what we added in the last term, that QS comma 0. That is the hoop stress. Okay. In the beam, the shear flow. So this finally, this term will be that must be equals to 0. Later, we will find this sigma del z by dz, and we will substitute here. Okay, so let's find del sigma z by del z. So first what? Moment by distance, that is, look, moment is what? Load into a force into perpendicular distance. So from here, del mb equals to sx by sx into del z. So from sx, del mb by del z. So now for stress is what? Force per unit area is a stress, right? So you can say just Sx equals to del sigma z by del z. So what will be that? This Sx Ixx minus Sy Iyxy by Ixx Iyy minus I square xy into x along x direction. Similarly for y, Sy Iyy minus Sx Iyy by Ixx Iyy minus I square xy into y in y direction. Now just substitute this value in previous equation. What we will get? This one. So after further simplifying, we will get this one. Then what? Along xx, xy and xx and yy we have xy direction is not there. So means I moment of inertia along I, that is along xy axis is 0. So just substitute here Ixy equals to 0 in this equation. So after substituting and simplifying, what we got? That QS equals, that I already explained. Now after substituting all the term, we got this one. Okay. Now, so overall our final equation again, what we are having in this, just what we did, we replaced T to TD. Okay, and when that is the open section that time. Okay, so just see here, which TD is T if the skin is fully effective. It's totally in carrying direct stress. Means if all the skin is carrying the direct stress, that time T will becomes equals to TD. And if it's not carrying, it's carrying only the shear stress, that time TD will be equals to 0. So this you have to take care when direct stress is there or shear stress is there. For shear stress, TD will be equals to 0. For if all the parts of the skin is carrying the direct stress, then TD becomes T. Okay. After that, this is a figure for which we have find. So here what we have seen, you see sigma z in this direction and Q1 is acting in this direction, Q2 and this small change in that one, that sigma z plus del sigma z, that a small change of this one is acting in this direction. Okay, so now taking moment and just equal to 0. So these two positive and these two sides, that's just opposite, so that will be negative and that should be equals to 0. So after taking moment, now further simplifying, first I already showed you that expanded and then simplified. After simplifying, we got this one. So again, just for this only, we wrote here in for x and y. So q2 minus qy for s, because this term only we got here in previous equation, just substituted that one. So in m form, in sx form, then just substitute in sx and sy form, depending upon the requirement. Okay, finally, so this will be like that one. Then next for the boom address. So what we have to find for BRV form, so just total will be, right, for the Q as this into this one plus this into this one also. So this is common, this and plus this one. Similarly, as y this term common, then this plus this one, the whole into. So after this here, so after further that equation is there, and here this hoop stress is added for the closed one. Once this hoop stress we will remove, that becomes what? The open section. Okay, so this is the reference part. The miss it's TGH Max and the 4th edition, you can just refer. Okay, from there you will get this derivation. So if you have any doubt, you can just comment. Okay, the video you can just directly contact me regarding your concept. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.